Welcome, fellow explorers. Today, we embark on a thrilling journey through one of geology's most perplexing enigmas, the Great Unconformity. Imagine a billion years of Earth's history, vanishing without a trace. That's right, a colossal portion of our planet's past simply missing. This geological phenomenon has baffled scientists for over a century, leaving us with more questions than answers. But fear not, for today we shall unravel this mystery layer by layer. From the majestic depths of the Grand Canyon to the remote corners of the globe, we'll delve into the theories, evidence, and implications of this massive gap in Earth's rock record. And be sure to stick around until the end, because we'll reveal a shocking fun fact about the Great Unconformity that might just change how you perceive the ground beneath your feet. Our story begins in the late 19th century, in the rugged terrain of the Grand Canyon. Picture this: a one-armed Civil War veteran named John Wesley Powell, leading a daring expedition down the treacherous Colorado River. As Powell and his team navigated the canyon's towering walls, they noticed something extraordinary. The layers of rock, typically stacked like a colossal layer cake, seemed to have a massive slice missing. Powell wasn't just any adventurer, he was a keen geologist. He recognized that this wasn't a simple gap, but a profound mystery etched into the very fabric of Earth's history. The rocks at the bottom of the canyon were ancient, formed over a billion years ago, but sitting directly on top of these ancient rocks were much younger layers, only about 540 million years old. It was as if a massive eraser had wiped away hundreds of millions of years of Earth's geological record. This observation marked the discovery of what we now call the Great Unconformity. Powell's find wasn't just a local curiosity. It sparked a geological detective story that continues to this day. As other geologists began to look for similar patterns around the world, they realized that this unconformity wasn't unique to the Grand Canyon. It was a global phenomenon, a worldwide gap in the rock record that hinted at some catastrophic event or process in Earth's distant past. The Great Unconformity became a cornerstone of geological study, challenging our understanding of Earth's history and the processes that shape our planet. It stands as a testament to the power of observation and the enduring mysteries that our planet still holds, even after centuries of scientific inquiry. While the Grand Canyon might be the most famous location of the Great Unconformity, this geological phenomenon is far from an isolated occurrence. It's a global mystery, with evidence scattered across continents, offering us a tantalizing glimpse into Earth's distant past. In North America, beyond the Grand Canyon, you can witness the Great Unconformity in the Black Hills of South Dakota. Here, ancient granite dating back 1.7 billion years is directly overlain by 540 million-year-old sandstone. The stark contrast between these rock layers is visible to the naked eye, a testament to the immense time gap they represent. Traveling north to Canada, we find another striking example in the Rocky Mountains of Alberta. Here, the unconformity separates billion-year-old metamorphic rocks from much younger Cambrian sandstones. The juxtaposition of these dramatically different rock types tells a story of immense geological change. Crossing the Atlantic, we encounter the Great Unconformity in Scotland's Northwest Highlands. This region boasts some of the oldest rocks in Europe, and the unconformity here marks a time gap of nearly 500 million years. The ancient Louisian gneiss, formed deep within the Earth's crust, lies directly beneath much younger Cambrian rocks. Even in the southern hemisphere, traces of this global phenomenon can be found. In Australia's McDonnell Ranges, the unconformity separates 1.8 billion-year-old metamorphic rocks from 800 million-year-old sedimentary layers. Each of these locations tells a part of Earth's story, a narrative of unimaginable timescales and dramatic changes. The global nature of the Great Unconformity suggests that whatever caused this massive gap in the rock record wasn't a localized event, but a worldwide phenomenon that reshaped the face of our planet. The Great Unconformity isn't just a curiosity for rock enthusiasts, It's a pivotal piece of Earth's puzzle that holds immense scientific significance. This global phenomenon represents a critical juncture in our planet's history, offering geologists a unique window into Earth's past and the processes that have shaped it over billions of years. Firstly, the Great Unconformity serves as a marker for a major transition in Earth's history. It typically separates the Precambrian rocks, which contain little evidence of complex life, from the Cambrian rocks above, which suddenly burst with diverse fossils. This transition, known as the Cambrian explosion, marks one of the most significant events in the history of life on Earth. The unconformity's position at this boundary makes it crucial for understanding the conditions that may have led to this explosion of life. Secondly, the unconformity provides valuable insights into the processes of erosion and deposition on a massive scale. The missing rock layers represent an enormous amount of material that was eroded away. Studying this gap helps geologists understand the forces capable of removing billions of years' worth of rock and sediment. Furthermore, the Great Unconformity challenges our understanding of plate tectonics and continental formation. The global nature of this phenomenon suggests large-scale geological processes that affected the entire planet, potentially linked to the assembly and breakup of ancient supercontinents. Lastly, it serves as a reminder of the incompleteness of the geological record. While rocks and fossils provide invaluable information about Earth's past, the Great Unconformity highlights that there are significant gaps in our planet's story. It encourages geologists to develop new methods and technologies to fill in these missing chapters of Earth's history. The Great Unconformity has spawned numerous theories as scientists attempt to explain this billion-year gap in Earth's geological record. Each theory offers a unique perspective on the dramatic events that might have shaped our planet during this mysterious period. One prominent theory suggests that the Great Unconformity resulted from massive glaciations during the Neoproterozoic era, about 720 to 635 million years ago. This hypothesis, known as the snowball Earth theory, proposes that Earth was almost entirely covered in ice. As these massive glaciers advanced and retreated, they could have scoured away enormous amounts of rock, creating the unconformity we see today. Another theory focuses on plate tectonics and the supercontinent cycle. Some geologists propose that the formation and breakup of the supercontinent Rodinia, which existed about 1 billion years ago, could have led to widespread erosion. As continents collided and separated, they may have caused uplift and subsequent erosion on a scale large enough to create the Great Unconformity. A more recent hypothesis suggests that the unconformity might be linked to a massive pulse of volcanic activity. This volcanism could have released large amounts of carbon dioxide, leading to acid rain that accelerated weathering and erosion of the existing rock layers. Some researchers have proposed that the unconformity might not represent continuous erosion, but rather multiple cycles of deposition and erosion. In this scenario, sediments were deposited and then completely eroded away multiple times before the preserved Cambrian rocks were laid down. Lastly, a controversial theory suggests that a series of massive impacts from space debris could have resurfaced large portions of the Earth, explaining the global nature of the unconformity. While each of these theories has its merits and challenges, the truth behind the Great Unconformity likely involves a combination of these factors, highlighting the complex and dynamic nature of Earth's geological processes. Erosion plays a starring role in the story of the Great Unconformity, acting as the great eraser of Earth's geological record. But we're not talking about the gradual wearing away of rock that we might observe in our lifetimes. Instead, picture erosion on a truly massive scale, capable of removing miles of rock over millions of years. Water, in all its forms, is a primary agent of this erosion. Rainfall, rivers, and glaciers all work to break down and transport rock material. During periods of high rainfall, rivers can carve deep valleys and transport sediment over vast distances. Glaciers, with their immense weight and slow movement, can scour landscapes, reshaping entire continents as they advance and retreat. Wind also plays a significant role, especially in arid environments. Over millions of years, wind-blown sand can wear away even the hardest rocks, creating vast deserts where mountains once stood. Chemical weathering, where rocks are broken down through reactions with air and water, is another crucial factor. This process can be particularly effective in warm, humid climates, rapidly breaking down certain types of rock. The effectiveness of erosion is amplified by tectonic activity. As tectonic plates collide, they can push up mountains, exposing more rock to the forces of erosion. Conversely, as plates pull apart, they can create basins where eroded sediment accumulates. The scale of erosion required to create the Great Unconformity is staggering. In some locations, it's estimated that up to 3 miles of rock were removed. This isn't just scraping off the surface, it's fundamentally reshaping the face of the planet. Understanding the role of erosion in creating the Great Unconformity helps us appreciate the immense power of these geological processes and the vast timescales over which they operate. Plate tectonics, the grand architect of Earth's surface, plays a crucial role in the story of the Great Unconformity. This theory, which describes how Earth's crust is divided into large plates that move over the planet's surface, provides a framework for understanding the massive geological changes that could have led to this global phenomenon. The movement of tectonic plates is a slow but relentless process, capable of building mountains, creating oceans, and reshaping entire continents over millions of years. During the time period associated with the Great Unconformity, Earth was experiencing some of its most dramatic tectonic activity. Around 1 billion years ago, the supercontinent Rodinia was assembling, bringing together land masses from across the globe. The immense forces involved in this assembly caused widespread uplift and mountain building, creating vast ranges that would later be eroded away. As tectonic plates collided, they pushed up mountains, exposing fresh rock to the elements. The newly uplifted rocks were subjected to intense weathering and erosion, especially in the high-energy environments near mountain ranges and along coastlines. Rivers and glaciers carried vast amounts of sediment away from these eroding mountains, depositing it in basins and forming new rock layers elsewhere. However, the story doesn't end there. About 750 million years ago, Rodinia began to break apart. The rifting and separation of this supercontinent created new coastlines and ocean basins, further influencing patterns of erosion and deposition. As the land masses drifted apart, they created new pathways for rivers and glaciers, altering the landscape on a global scale. The tectonic upheaval associated with the assembly and breakup of Rodinia likely played a significant role in creating the Great Unconformity. The immense forces involved in these processes would have been capable of eroding vast amounts of rock, leaving behind the stark geological record we see today. This dynamic period in Earth's history highlights the power of plate tectonics to shape our planet's surface over geological timescales. Ancient climatic events, particularly glaciations, might have also contributed significantly to the formation of the Great Unconformity. During the Cryogenian period, which spanned from approximately 720 to 635 million years ago, Earth experienced some of the most severe ice ages in its history. These snowball Earth events, as they are often called, saw glaciers extending to equatorial regions, covering much of the planet in ice. The massive glaciers of these periods would have had a profound impact on the Earth's surface. As glaciers advanced, they ground down rocks beneath them, scraping and scouring the landscape. This glacial erosion would have been particularly intense in mountainous regions and other high-relief areas, stripping away vast quantities of rock and sediment. When the glaciers eventually retreated, the meltwater would have carried this eroded material away, further contributing to the widespread removal of rock layers that characterizes the Great Unconformity. Moreover, the cyclical nature of glaciations, alternating between periods of intense cold and warmer interglacial periods, would have created repeated opportunities for erosion and sediment transport. Each glacial advance and retreat could have removed more material from the Earth's surface, gradually creating the dramatic unconformity we observe today. The Great Unconformity provides a unique window into Earth's history, revealing patterns of stability and upheaval that have shaped the planet over billions of years. This geological phenomenon underscores the dynamic nature of Earth's surface, where periods of relative calm are punctuated by episodes of intense tectonic activity, climatic shifts, and biological evolution. The erosion that created the Great Unconformity marks significant geological events, such as the assembly and breakup of supercontinents, shifts in climatic conditions, and the movement of tectonic plates. These processes are not isolated. They interact in complex ways, driving the evolution of Earth's surface and the life it supports. For instance, the erosion and weathering associated with the Great Unconformity may have played a role in enriching the oceans with nutrients, potentially contributing to the Cambrian explosion. Understanding the Great Unconformity also helps scientists reconstruct past environments and climates. By studying the rock layers above and below the unconformity, geologists can infer changes in sea levels, climate conditions, and the types of ecosystems that existed at different times. This information is crucial for piecing together the history of life on Earth and understanding how past events have shaped the present-day planet. The Great Unconformity continues to be a subject of intense scientific research, with geologists and other Earth scientists striving to unravel its many mysteries. Advances in technology and analytical techniques are providing new tools for studying this geological phenomenon, offering the potential for significant breakthroughs in our understanding. One area of ongoing research focuses on using high-precision dating methods to establish more accurate timelines for the periods of erosion and deposition associated with the Great Unconformity. By refining these timelines, scientists can better correlate geological events with other major occurrences in Earth's history, such as climatic shifts and biological evolution. Another promising avenue of research involves the use of geochemical analysis to trace the origins of sediments and understand the processes that transported them. These studies can reveal details about ancient weathering rates, erosion patterns, and the chemical composition of the Earth's surface during different geological periods. Field studies also play a crucial role in advancing our knowledge of the Great Unconformity. Geologists continue to explore and document unconformity sites around the world, from the Grand Canyon to remote regions of Antarctica. These field investigations help to build a more comprehensive picture of how the Great Unconformity formed and its significance in Earth's geological history. Future discoveries may also come from interdisciplinary research that integrates geology with other scientific fields, such as biology, chemistry, and climate science. By examining the connections between geological processes and the development of life, researchers can gain new insights into the interplay between Earth's physical and biological systems. As we continue to study the Great Unconformity, we move closer to unlocking the secrets of Earth's ancient past. This ongoing research not only deepens our understanding of geological processes, but also sheds light on the broader history of our planet and the life it sustains. Each new discovery brings us one step closer to fully comprehending the dynamic and ever-changing nature of Earth. The Great Unconformity is a testament to the power of natural forces to shape our world, reminding us of the intricate and interwoven history of our planet's geological and biological evolution. It stands as a symbol of the enduring quest for knowledge, inspiring future generations of scientists to explore, investigate, and uncover the mysteries of our incredible planet. As we conclude our journey through the mysteries of the Great Unconformity, It's clear that this geological phenomenon is more than just a missing chapter in Earth's history. It represents a profound story of transformation, shaped by the immense forces of erosion, tectonics, and climatic change. From the rugged depths of the Grand Canyon to the remote highlands of Scotland, the Great Unconformity challenges our understanding of geological processes and highlights the dynamic nature of our planet. But before we part, here's that shocking fun fact we promised. The Great Unconformity isn't just a feature of Earth's past. It's a reminder of the planet's ever-changing nature. Even today, erosion and tectonic activity continue to reshape the surface of the Earth. The processes that created the Great Unconformity are still at work, slowly but inexorably altering the landscape. This ongoing activity means that future geologists might one day study their own Great Unconformity, piecing together the history of our planet from the clues left behind. So, the next time you gaze at a majestic canyon or a towering mountain range, remember that you're looking at the results of billions of years of geological activity. The Great Unconformity serves as a humbling reminder of the vast timescales and powerful forces that have shaped and continue to shape our world. Stay curious, fellow explorers, and keep seeking out the mysteries of our incredible planet. Thank you for joining us on this mind-bending journey through Earth's hidden past. If you found this exploration of the Great Unconformity fascinating, we invite you to support our channel, Armchair Archaeology, by giving this video a thumbs up and subscribing for more captivating dives into Earth's mysteries. Don't forget to hit the notification bell to stay updated on our upcoming geological adventures. We're eager to hear your thoughts. What other geological enigmas would you like us to unearth next? Share your suggestions in the comments below. Until our next discovery, keep exploring, keep questioning, and remember, the ground beneath your feet holds secrets billions of years in the making.